Hi guys, Mrs. Rossi here. Today we're going to be talking about different states of matter. You should have your class note sheet, and as we talk, you should be filling it out. If you need to pause the video at any time, please do so. If you need to go back on the video at any time, please do so. You should have already done the true or false questions on your class note sheet about different properties of solids. We're just going to review them now. So look back to the true or false questions. The attraction between particles of a solid are weak. This is false. They're actually very strong. The particles in a solid move. This is true. We're going to be talking about this more in just a little bit. The particles of a solid can vibrate. So if they can move, then they can vibrate, and that's actually a more accurate descriptor of what they do. So also true. Particles of a solid are arranged in repeating patterns. This one, false. This is sometimes true, sometimes false. So it's not always true. So false is going to be our answer. There is more than one type of solid. Going back to what that last one just was, this is true, and we're going to be talking about those in a little bit as well. All right. You also have one more thing on your note sheet. KMT stands for kinetic molecular theory. This is true, and we've talked about this many times in class. As I talk about solids, you're going to be filling out the grid that's on your note sheet. So I'm looking for you to write the definition of solids, describe how particles in a solid move, draw a picture of what the particles look like, and just give me at least 2 examples of things that are solid. All right, so a solid is a state of matter that has definite shape and definite volume. So even if you put a solid into a container, it's going to retain its own shape and not conform to the container that you put it in. The particles in a solid substance are very close together, so very, very tightly packed. And the attraction between them is stronger than the attraction between particles of the same substance in any other state. So very strong attraction, packed closely together, but they do still move. You can describe them as vibrating in place. So there's not a whole lot of movement going on, but there is some movement going on. The particles of a solid can be arranged in different ways. Depending on the type of arrangement, there's different types of solids. So this first one over here, we have crystalline solids. This is our first type of solid that we're talking about. This has the very orderly 3D repeating pattern. So here we have a diamond, and then a diamond is an example of a crystalline solid, which has the repeating pattern of carbon atoms that are all linked together, and the pattern repeats itself. Some other examples are ice and iron. The other type of solid that exists is an amorphous solid. And just like its name, like morph, it kind of morphs into whatever it needs to be for those particles to lock into place. So some examples of amorphous solids are glass, rubber, wax, and all those particles are still tightly packed together like you see here in the glass diagram, but they don't have that same repeating pattern. So when you look at these, we have wax, which would be amorphous. We have, we have a repeating pattern, so this would be crystalline. Right here you can tell just by the crystals, crystalline, and then an example of an amorphous solid. Take a minute, you can pause the video if you need to arrange these properties into something that describes a solid and something that does not describe a solid. You're going to do this on your note sheet. Check your answers. How did you do? Hopefully you got them all right. If you didn't get them all right, you can scooch them over into the columns that they need to be in. All right, up next we have liquids. You're going to do the same thing. You're going to fill out the chart on there to include the definition of liquids, describe the particle movement of liquids, draw a picture of what those particles look like, and give me some examples. So a liquid is a state of matter that has definite volume, but not a definite shape. Liquids take the shape of the container that they are in. The particles of a liquid move fast enough to overcome some of the attractions between them. They slide past each other. So solids, we said, vibrate in place. Liquids slide past each other. So they're able to overcome some of that attraction between the particles, but there is still some. Even though they can easily change shape and take the shape of the container they're in, they don't change volume. So it doesn't matter what container you put it in, the volume of that liquid will still be the same. Liquids have some special properties that we're going to be investigating in class as well. The first one is adhesion. Adhesion is the force of attraction between unlike molecules and the water molecules attracted to the sides of the container. So if you look here, it's supposed to be kind of an example of kind of what you see happening in a graduated cylinder. We talked about the meniscus earlier in the year. Here we have water, and then we know our graduated cylinder is either made out of plastic or glass, and that water kind of creeps up the side to make that curved meniscus line at the top. So the reason it does this is because of adhesion. It's the attraction of those water molecules to kind of climb up the sides of that container they're in. And the container they're in is not made out of the same substance as the water. The other property you need to know about liquids is cohesion, the force of attraction between like molecules. So here you see the cohesive forces of water too. We talked about this a little bit with the hydrogen bonding that we talked about in our last chapter. So water molecules are attracted to themselves. We have the negative oxygen or more electronegative oxygen atom, and then the more positive hydrogen atoms, and they kind of link up and line up and kind of work together to build on top of each other. If you've ever done the penny lab where you try to pile all the water droplets on top of each other on top of a penny to see how many you can fit, you've seen cohesive forces in action. And then the last property of liquids that you need to be aware of is viscosity. Viscosity is a liquid's resistance to flow. So different liquids have different attractive forces between them. It's not all the same. Everything doesn't flow as easily as water. Think shampoo, conditioner versus water versus soda. All that stuff has different viscosities, even though they're all technically classified as liquids. Something like honey that flows slower than water would say that honey has a higher viscosity, or it's more viscous than water. Here's a real life example for you as well. So motor oil, something that your car needs to run, if it's too thick or heavy, you're going to have more friction and reduced efficiency of your engine. However, when it's cold out versus when it's hot out, you might want to change or be aware of the temperature limits of your motor oil, because it could get too thick and cause more friction, or maybe not enough, and you could be wearing down your engine parts. All right, and then our last state of matter that we're talking about today is gases. Once again, fill out the definition, describe how those particles move, give me a picture of the particles, and give me some examples. Gases are the state of matter that has no definite shape or definite volume. The particles of a gas move quickly, so quickly that there is little to no attraction between them. They do have some attraction just because they are matter and all matter is attracted to other matter, but really not enough, and definitely not like you see in the solid or liquid state to have that much of an influence. So the amount of empty space between gas particles can change because gases are compressible. So depending on the shape or size of the container, the gases are going to spread out as far as they possibly can. We know gas pressure is caused by those particles hitting into the sides of the container, and depending on the container, it can be either really high or really low. And then here are some examples of the particles. We know gas pressure is caused when those particles hit the sides of the wall. Think back to our gases unit with 3 properties that affect the behavior of gases. Remember, we had our sticks that gave us the clue. We have temperature, pressure, and volume that all influences how gases behave. At this point, if you need to rewind the video at all, you can. If you need to go back to any part, you can, but everything on your States of Matter class note sheet should be filled out.